I'm going to show you here how you can use the idea of oxidation states or oxidation numbers to work out during a reaction what has been oxidized and what has been reduced. So I have a fairly complicated equation here. Let's start by assigning oxidation states. So bromide, it's a simple ion. Oxidation state is the same as the charge on the ion, so it is -1. Hydrogen here, simple ion, +1. Hydrogen in sulfuric acid, well, hydrogen nearly always has an oxidation state of +1 unless it's a metal hydride. That's not the case here. So hydrogen there is +1. Oxygen, again, unless it is in a compound with fluorine, is going to have an oxidation state of -2, which means because I've got 4 oxygens and 2 hydrogens, sulfur here must be +6. Bromine in the products is an element. Elements always have an oxidation state of 0. Sulfur dioxide, well, if oxygen is -2 and there are 2 of them, sulfur must be +4. And in water here, I've got hydrogen as +1 and oxygen as -2. So, oxidation is when an element has an increase in oxidation number or oxidation state during the course of the reaction. So let's look here. I've got bromine. Bromine starts off at -1 and it ends the reaction at 0. So we can say that the oxidation state or number has increased. So this is definitely oxidation. So oxidation is an increase in oxidation state during the course of the reaction. If something has been oxidized and somebody else has been reduced, reduction is a decrease, obviously, in oxidation state or number during the course of the reaction. And we can see that that is what has happened to sulfur. Sulfur started off at +6 and ended up as +4. So oxidation state has decreased. So this is reduction. A second example. Let's start by assigning oxidation states. So to begin with, chlorine is an element. Oxidation state of all atoms and elements is 0. In the hydroxide ion, I've got oxygen at -2, hydrogen at +1. Overall, the oxidation state of this ion equals the charge on the ion. Chloride here is a simple ion, so oxidation state is the charge on the ion. In my chlorate ion, I'd have oxygen at -2, so chlorine must be +1, because +1 minus 2 equals a single negative charge on the ion. Water, hydrogen is +1, oxygen is -2. Remember, we're always stating the oxidation state or number for the atom, individual atom in our element, or compound or ion. So let's have a look at oxidation and reduction. So oxidation is an increase in oxidation state. So chlorine here has gone from being an element at 0 to +1 in the chlorate ion. So we have oxidation. In this particular example, chlorine has also been reduced because the chlorine molecule ends up as 2 ions and 2 different compounds, and we've got a decrease in oxidation state there, so chlorine has also been reduced. This is not uncommon, and it is known as disproportionation, or disproportionation reaction, where an element is both oxidized and reduced during the same reaction. If this has been useful, hit the subscribe button, the effortless way to support your studies, and by clicking the link in the description below, it'll take you straight to Crunch Chemistry School, where you can access my free math skills course, complete tuition, and worksheets designed specifically to build your confidence and stretch you. Together we can do this.